Welcome to Study Loop.
This is a question on the Rayleigh criterion of resolutions. So we have Hubble Telescope, which has a diameter of 2.4 centimeters. I'm sorry, 2.4 meters, and the Arecibo telescope, which has the radius, the diameter of 305 meters. Now, both of these are looking at the moon. So we want to look at a crater on the moon. Notice that the distance at which Hubble telescope moves around the Earth is insignificant compared to the distance between the Moon and the Earth, which is of the order of 10 power 8. The distance between Moon and Earth is 3.8 into 10 power 8 meters, whereas telescopes usually have orbits of the order of kilometers, which is 10 power 3 which is 10 power 3 meters. So we can safely ignore this distance, and we can think of both the Hubble telescope and the Arecibo telescope as being at the same distance from the Moon. Now, we know that the Rayleigh criterion is sine theta is equal to 1.22 lambda by d. Now, sine theta in this case is the width. Let's say this is our crater and this is our telescope. Assume these two are straight lines. It's a little hard to draw straight lines here, but well, this angle is theta. We know that because this angle is very small, we can see that sine theta is almost equal to theta. And we know that theta is the arc length divided by the radius, which is the diameter of the crater divided by the distance between the moon and the earth. Let's call it s. Therefore, d by s is equal to 1.22 lambda by d. So the diameter of the crater you can resolve successfully is 1.22 lambda s times d. So we simply substitute this for both the cases, for Hubble and Arecibo. Now, for Hubble, lambda is equal to. Now, remember that we want to see the best resolution, which is the smallest resolution. And as you can see, resolution is directly proportional to lambda. So we will choose the smallest lambda possible. And in the visible spectrum, that corresponds to the blue light, which is 400 nanometers, which is 400 times 10 power minus 9 meters. So d is equal to 1.22 times 400 into 10 power minus 9 times s is 3.8 into 10 power 8 divided by, I'm sorry, yes, that is good. And the d is the diameter of the telescope, which is 2.4 in this case. Using this, by substituting into a calculator, we'll see that the diameter of the crater that we can resolve is 77 meters. And for Arecibo, lambda is 75 centimeters, which is 0.75 meters. So the diameter of the crater is simply 1.22 times 0.75 times 3.8 into 10 power 8 by the radius, the diameter of the telescope is 305. This gives us 1.1 into 10 power 6 meters. As you can see, the Hubble telescope has a much better resolution than the Arecibo, just because of the wavelength difference, even though it's a much smaller telescope. So why do we use Arecibo? We use Arecibo for other things. We use Arecibo because visible spectrum, visible light is usually absorbed by interplanetary clouds. And that is why it's important to have telescopes in non-visible ranges of electromagnetic spectrum. Now, we want to find out what would be the height from which Hubble telescope would have to look at Earth in case we want to uh, resolve a license plate, not the letters on the license plate, but the license plate itself. We know that license plate has the dimensions of about 20 centimeters, so that's about 0.2 meters. And by simply substituting it, we should be able to see that. Now let's open a new sheet. Now we know that 1.22 lambda by the diameter of the telescope is equal to the resolution diameter divided by the distance. So we want this d to be the size of a license plate, which is about 0.2 meters. So we know S is equal to d by 1.22 lambda. So now we know that d is the diameter of the telescope, that's 2.4 meters. We know that, capital D is the resolution, which is 0.2 meters. The size of a license plate times the diameter of the telescope is 2.4 divided by 1.22. And now we want this, it depends on what wavelength we are using, but let's go by blue because we already use blue. So blue is 400 nanometers. So that's 10 power 400 times 10 power minus 9 meters. This gives us 1.18 times 10 power 7 meters. This is the height at which the Hubble telescope has to be to resolve a license plate.